Okay, we had better start. Welcome to 4th International Symposium on Multidisciplinary Studies and Innovative Technologies. My name is Mehmet Emir Köksal. I have been working as a professor in the Mathematics Department of 19 Mayıs University, established in Samsun, the coastal city of the Black Sea region of the Turkey. We organized this conference online this year due to the virus occupying the world urgently. I hope you will get through this process without any problems.
Hi Mehmet, it's nice to meet you.
Nice to meet you.
My name is Malik, and I just wanted to ask about the time slots we have. How much time?
Okay. The duration of each presentation is 15 minutes, and we have 8 presentations in this session. Hassan, welcome. And Hassan? Hassan? So the name of the first speaker, Mahdi Hassan Aysam, and the title of his talk is IoT DDoS attack detection using machine learning. Hassan, you can start your presentation.
Okay. Hello, everyone.
Hello. You can start and you can share your screen. Hassan?
Yes.
You can share the screen of your computer.
I have a
Okay, Malik, then you can start to give your presentation. He has disconnected, okay?
All right, sure.
Okay.
Okay, let me share my screen and start. Right, can you see my screen?
Sure, right.
Okay. Okay, just a second, I want to get into present mode. And all right.
Right.
First of all, the title of my paper is Android App Testing, a model for generating automated lifecycle tests. The main author is myself, Malik, and my co-author is Dr. Samer Zain. And first of all, no model-based research exists to test Android applications, lifecycle methods, conformance, and our goal in this research is to build a framework to generate such a model. We then evaluate our model in 2 different methods. The research objectives we have for this paper are to investigate how to generate a model to represent lifecycle callback methods from the perspective of system resources, and design a framework to extract such a model using static code analysis techniques, and also extend this framework to generate and execute automated tests from the extracted model. And when it comes to approach and implementation, the model we propose we propose building a model of the Android lifecycle callback methods, then use this model to generate unit tests, tests in general, and finally execute these test cases and analyze the results. The lifecycle callback model will be the base of our test case generation. The following figure depicts our model and its 4 phases. And in this phase, we have the first phase, we have the parser. The second one, we have lifecycle method analyzer. Fourth phase, we have assertion usage model. And last, we have the Android usage report. And the model are displayed in the green, and the output of each phase is the blue one. Now, the model phases, the first one of the model phases is the parser. This is where the Android source code is first consumed. Each activity fragment or app compat activity is consumed from this Android source code using static code analysis techniques. Now, one activity fragment or app compat activity is parsed at a time until all of them are parsed. And we only parse the lifecycle methods inside those files. The output of this phase, we call it abstract syntax tree model. Now, this is an example of what an abstract syntax tree looks like. And when it comes to the lifecycle method analyzer, which is the second phase, it consumes the abstract syntax tree, which is the output of the first phase. And we use this abstract syntax tree, or AST, as an abbreviation to build a graph for each activity fragment or app compat activity of the Android app. Now, each graph represents the activity lifecycle methods and the transitions between these methods inside each activity fragment or app compat activity. Now, each node in the graph contains lifecycle method, and the edges are the transitions between those activities. Inside each one of those nodes, we also include the resources in terms of like camera, GPS, or external drive that this lifecycle method uses. For example, the on resume, we add the camera as acquired, for example. Now, the lifecycle method analyzer, we have this sample graph to show the model that this phase builds. And we have 2 lifecycle methods. We have the transition, we have on resume and on pause, and the transitions between each of those. And inside, for example, the on resume lifecycle method, we have the camera acquired, we have the GPS acquired. Now, in the on pause, we have the camera released. And this is the kind of information we include in each one of those nodes. Now, this phase produces a directed graph for each activity fragment or app compat activity in the Android app, and similar to this graph. Now, in order to help visualize and see the results of this phase, the graph for each activity is printed on a separate file. We implemented this model using Java language. And to mimic this graph, we print the output of each activity to mimic the nodes on a separate text file. And we follow this format right here. We have on resume, we have the method, the resources acquired and released inside each of these methods, and the transitions represented by this arrow between each activity and the other. Now, the third phase is the research usage assertion model. We build lifecycle test assertions to make sure each resource, the resources we specify here, the camera, location, and external drive, is acquired and released in the right lifecycle method. These assertion tests take into consideration 3 resources as a set of predefined model rules to check for assertion. In this model-based tool we present, we implement assertions for the camera, the location, or GPS, and finally the external drive. Now, we choose these 3 resources because they're among the most commonly used system resources by Android apps. The model-based solution approach we built has a property file in the code itself, in the Java code, where we define resources and the rules for each one of those resources, where it's let go, where it's caught, and etc. And this property file is managed by the developer And it gives, for example, a developer wants to build an Android app, wants to test it, they can go to this property file, configure it to fit their needs, add more resources, remove resources, etc. Now, the resource usage assertion model property file, which configures this model, the rules for this model, where each resource is caught or released. For each resource, we define the name, the way the resource is caught, and lifecycle methods, where the resource can be acquired, the resource methods, lifecycle methods where the resource can be released, etc. Now, for example, the camera we have, the way we check for a camera in this model, in the code, in the implementation, we search all lifecycle methods for camera object instance, which acquires the camera. This object instance looks something like this: camera instance variable. We define how we use the open method, which acquires the resource, and this object usually initializes inside the onResume lifecycle method, and the model checks. But however, the model checks in all lifecycle methods, the on pause, on start, on in all the methods, not only on onResume, to check for incorrect catching of resources. But the right way to catch it is inside the onResume lifecycle method. And in the Android, the camera is also can be acquired in one of two ways as of Android version 11. So we check for both methods of acquiring the camera. One way is using the camera, something it's called camera object instance. The other way is called from the system services. We check for all the ways that a camera can be caught in the Android system, and we check if it's caught or released. Now, let me see here. The location object, we do the same exact thing for location. We specify how the location is caught in the Android source code. I don't want to get too technical details. Now, I want to get to the resource usage report phase. This final phase of the model presents the assertion results for checked resources. In short, we check for each one of those three resources: the camera, GPS, and location. We check where it was caught, where it was acquired by the Android system, by the app from the Android system, in the onResume lifecycle methods. For example, they were caught. We check where they're released in any other method, for example, the onPause. If the resource is released, we print pass for the user. If it's not released, we print fail. We provide a report why it failed, because you did not use the, for example, for the camera, you did not release the camera in the onResume lifecycle method. And also we check, we insert comments inside the source code, the Android source code, for the developer to tell them, well, this is where you should release this resource. You should build an onPause method. You should use this object inside this onPause method so you can release the resources and like prevent bugs in your application. This is an example report on the UI of the application. So each one of those is an activity, fragment or app compat activity. For example, camera to video fragment is a fragment. Android camera API.java is an activity file. Now, the camera2, we call this variable camera2. It failed because the developer did not release it. We detected the variable, which is mCamera device, that was used to catch the camera, and we also detected that it was not let go. We proposed letting this resource go in the onPause method. We also insert comments inside the code like this. This to do comment here. We tell the developer you must release the camera by using the hash is used for variable name .close method in the onPause or onDestroy lifecycle methods. So we provide recommendation for developers on how to use this tool. That's based on our model. Now, the evaluation part for this model that we implemented into a tool. We evaluate it in two ways. The first one is using user evaluation test, an approach used before by Barnett et al. And the references we mentioned. And the second one, we propose seeding bugs into 10 different Android applications, real-world Android applications. And this method was also used by Zain et al. In another research. Now, the first method to conduct user test validation, we asked 6 Android developers to fill out a demographic survey prior to starting an experiment. This helped identify the level of experience for those developers undergoing the experiment. After that, the participants watched a short learning video on how to use the automated testing application on a provided sample Android application. And the learning video helped us reduce bias and at the same time run the experiment for multiple users instead of going after them one by one. The experiment setup went as follows. The developers filled out a pre-experiment demographic survey. They watched the learning video after that and on how to use the tool we built. And finally, they completed a programming task. Finally, they filled out an evaluation survey. The second evaluation method is we had 10 Android applications from different domains, different sizes, different complexities. We seeded bugs into those applications, and then we checked the ability of our tool to detect those bugs we seeded. The evaluation of the 10 Android applications aimed at evaluating our tool's ability to detect the correct and incorrect release of acquired Android system resources. These are some of the applications we test. And the evaluation of the open source applications, we had 3 phases. First, we manually checked for the source code for any bugs to make sure we don't have any lifecycle method errors and what lifecycle methods are being used. After that, we checked acquisition and release of each system resource and if it was invoked in the right lifecycle methods. The second phase in the evaluation of the Android applications, we actually aimed to detect the wrong release of system resources. We modified the source code, we injected bugs to check if our tool could detect acquired and released resources. And our tool successfully detected all the bugs we seeded. And we actually, in the third phase, we aimed at detecting whether our tool can check for the correct release of resources. So we fixed those bugs again, we ran the tool again, and our tool could actually detect that the resources were correctly released. Now, in terms of results, the user evaluation, the majority of the responses for the 6 Android developers we had for the first evaluation method, around 90% of all participants strongly agree to 14 of our 15 questions. These strong results confirm that the proposed model and the model-based tool is suitable for usage by professionals and Android developers. And about 85% of those participants agree or strongly agree that our tool is fairly easy to use and it's easy to learn how to use it. And also it's easy to find the to-do comments that this tool we propose injects into the source code. So it helped those developers perform programming tasks better and fix the resource bugs they have. And it's easy to remember because they had to rerun the tool once they fixed the errors. And so the tool gave them comments on how to fix bugs. They ran the tool again. The tool, it was easy to remember how to use it again, and it detected the correct bug fixes. And I just want to get quickly to the application evaluation. The application 10 Android application evaluation, our tool successfully detected all correct and incorrect releasing of Android system resources. For all three incremental scenarios we checked, we presented, and the execution results for the execution results for 2 of those 10 applications go as follows. As you can see, that we could check that we detected that incorrect release of the antenna pod application external drive, and the correct release of the food cam and applications activities. The camera and external drive passed. Those are 2 example screenshots of the tool we have. And on average, 8 of the 10 applications we tested have the execution time is actually 780 milliseconds. This shows that our tool can analyze, parse, and check for resource acquisition and releasing for each of the 3 resources for a relatively large mobile app in a short time, just 780 milliseconds. The last 2 applications are Telegram and WordPress. These are huge enterprise applications having hundreds of activities, and our tool takes about 14.5 seconds on average to analyze such applications. And we presented some threats to validity, and I don't want to get into those details a lot, but I will just present a little bit of future work. Our future work may include enhancing our suggested model to automated generated and insert the code that actually releases the system resources automatically, not just insert comments. Like, we could potentially insert lifecycle methods to fix the bugs, and also generalize this model to cover iOS applications as well as Android applications. And we could cover more resources, plus the camera, GPS, and external storage. Thank you.
Thank you for your presentation. Is there any question, comments, or remark? No question. Thanks again for your presentation.
Okay. Thank you.
The next speaker is Dr. Mary, and the title of the talk is Robust Image Watermaking Using DWT CYD Chirp as an LU Decomposition.
Hello, good morning. Can you see my screen, please?
Yes.
Okay. Hello, good morning, everyone. My name is Dr. Mary, and I'll be presenting a study on robust image watermarking using DW, SVD, ChipZ, and LU decomposition. This is the outline of the study. I will start by introducing the study. I will talk a bit on digital watermarking. I will talk on the proposed approach. I would also be talking about the performance evaluation. I will talk about the impressibility test and the robustness test. The exponential increase of the multimedia technology has really increased, and this has made communication easier. It is more convenient, quicker. We can easily share our digital content over the internet, and we can easily communicate via all the multimedia technologies using the public internet. It has provided a lot of advantages by making us having a simpler communication platform, making it convenient to communicate over long distances, and making communication easier, and making us to share multimedia data across multiple platforms. But this has also led to several security issues, and it has brought about infringement on digital content. Basically, we'll be talking on images, because multimedia consists of images, video, audios, and text. But this study focuses on just the images. And these days, we see that images are available over digital platforms. And because most people in the world are connected to the public internet, so there is easy access to our images. There is illegal usage of these images, unauthorized manipulation of the images, unauthorized modification, and unauthorized reproduction of digital images. So in order to solve this, it has been known in the literature that digital watermarking has provided a solution to protecting digital content from illegal duplication, modification, and distribution issues. Digital watermarking is simply a method that enables you to embed a multimedia into another multimedia for several reasons, for copyright protection, for authentication, for fingerprinting, and so many other security protection measures. And in order to have a very good watermarking scheme, we generally categorize it or test it against two main factors. One of the factors is the imperceptibility. And when we talk about imperceptibility, we refer to the quality of making sure that our watermarked image is, the quality of the watermark image is not degraded after another multimedia data is being inserted into it. So we need to make sure that after inserting a watermarked image for security reason, the quality, the visual quality of the multimedia image or the is not degraded. The other one is the robustness. Most times our digital images go through several signal processing operations. And this signal processing operation is usually referred to as attack. And some of them can be cropping, some of them can be enlargement, some of them can be filtering, some of them can be just blurring, and so many other signal processing operations. The ability of the watermarked data to withstand such signal processing operation without being corrupted, and we can still retrieve it back from the watermarked image, is what we know as robustness. So basically, I have proposed an approach, and this approach is based on 4 frequency domain approaches, which is discrete wavelength transform, chip Z transform, lower and upper decomposition method, and singular value decomposition. And this is a combination of 4 frequency domain approaches, which combines the advantages of this approach. And basically, this is to satisfy the robustness and imperceptibility characteristics of a good watermarking. And we need to test to see if it is the visual perception of the watermarked image is going to be greatly improved. And we need to check if it can be robust against common signal processing operations, which we generally refer to as the attack. So we have, this is the flowchart of the proposed algorithm. And in the proposed algorithm, we have the original image, which is being decomposed by the discrete wavelength transform. And it's when you decompose a signal using discrete wavelength transform, it gives 4 basic subbands. It gives the low-low, the low-high, the high-low, and the high-high. The main information is contained in the low-low of the frequency subband, and it is generally robust against signal processing operation attacks. So we have further decomposed the low-low subband using the chip Z transform. And the signal gotten from this is further decomposed with LU decomposition. And it came up with 3 matrices, where the diagonal matrix is being further decomposed using singular value decomposition, which also gives us another 3 matrices, and we have used the singular value. The singular value is used because a slight change in the singular value will not affect the visual perception of the used signal. So we have combined this with the watermarked image, which was decomposed using the singular value decomposition. And we also use the singular value of the watermarked image, since a slight difference will not affect the visual perception of the image. A combination of these, and we have reversed the inverse chip Z, inverse DWT to give the watermarked image. So this is the embedding process. This is the flowchart of the embedding process of our proposed approach. And while we tried to extract the watermark, basically we are using the non-blind watermarking approach. And in the non-blind watermarking approach, the watermarked image, the original image, and the watermark image is needed in the extraction process. So the watermarked image is decomposed, like earlier explained in the embedding flowchart. It is decomposed up till the singular value decomposition. Also, the original image is further decomposed, and the watermarked image is decomposed. And we had to extract the singular value decomposition and check the main value of each of the pixels to see if they are negative or positive. So according to, if they are negative, we can actually make it 0, or if they are positive, we make it greater than the pixel value of the watermark image. So this is how the watermark was extracted. And after extraction, we tried to find if the embedding of the watermark, after embedding the watermark, we could still check if the visual quality of the watermark data is not degraded. And we also tried to test for the robustness of our approach. Now, in order to evaluate the performance of the algorithm, we have used three common or three most used test images. These images are retrieved from the test database. And we have used the cameraman, the learner, and the baboon image. And we have used the A alphabet as the watermarked data. So these three images are the cover images, and the A image is the watermarked data. And after embedding on the A alphabet on the cameraman, we can see from here that the visual quality of the watermarked data is not affected. And we also see that the learner image is not affected and the baboon image is not affected. This is also the extracted watermark image after it has been embedded and extracted. Actually, this is the one extracted from the cameraman image, and we can see that the quality is not degraded. So this can show that without attack, our the proposed algorithm is imperceptible and robust against signal processing operation. Then we further test it by comparing with a study of Jane and Elbasi. In this study, we have used the cameraman, learner, and baboon image. And we have used the commonly used imperceptibility test, which is the peak signal to noise ratio, to check to compare our proposed technique against that of the Jane and Elbasi. And as you can see, we have higher PSN value in dB. Our PSN value outweigh that of the Jane and Elbasi, showing that we have a better result than what we have in the literature. We have further done that using some form of filtering, scaling, and rotational attack according to what they had in their study. And their PSN value is not very far from ours when the watermarked image has undergone these attacks. So the cameraman, watermarked cameraman underwent the filtering, the scaling, and rotation. And we have a very similar result, although our result is slightly higher than that of the Jane and Elbasi, but we still have a very good quality watermarked image. So this is also for the learner and the baboon images. And you can see that some of them are slightly higher than, some of their results is slightly higher than ours. Like for the baboon image, for scaling, we had 22.48 against this, which is slightly higher. And for rotation is slightly higher. And we see that because of the intensity of the baboon image, our proposed approach does not do well as compared to that of the Jane and Elbasi, which is a study published in the literature. Now, this is also the visual perception of the watermarked image that has gone through several other attacks. And you can see that we can, although some of them might have like the gamma correction, the Gaussian noise, the salt and pepper, but most of the attacks, we can still say that the quality of the watermark data was not degraded under the attack, as most of us can still see the image. It might not be clear, but we can still see it in some form, which is still in line with what we have in the literature. Now, going to the robustness, we have used similarity ratio, which is also used in the literature to compare the watermark image and the extracted watermark image. And we have tested this again against a study in the literature, which is the Jane and the Elbasi. And after extracting our watermark, you can see that we still have very good SR values, showing that most of the attacks, we could still retrieve the watermarked image, although for rotation, it is very low for cameraman. But for the other filtering and scaling, our approach is still robust against this signal processing operation. And we have come up with several other common signal processing operations. And if you look at this, you can see that our approach is robust against common signal processing operation. This is the visual quality of the extracted watermark after it has undergone the attack. So as you can see, rotation and filtering was very low, and JPEG also very low. And actually for JPEG, it is not robust against JPEG, but as you can see, it is robust against most signal processing operation. And so we can conclude that our proposed technique has been tested on multiple signal processing operation, and the experimental results shows that our watermarking technique has a very high imperceptibility capacity, and it is also robust in diverse signal processing operation. Thank you so much for listening. I will be available to take any questions, please.
Thank you very much for your presentation. Is there any question, comments, or remark? Thanks again for your presentation.
Thank you so much. Thank you.
Now, the next speaker, Mrs. Marwa, the title of the talk is Magnetic Resonance Imaging for Brain Tumor and User Risk Classification Using Recurrent Neural Network.
Yeah. Hi, sir.
Hi.
I'm glad to meet with your conference.
Thank you. The duration of the presentation is 15 minutes.
Just a minute,
and
please.
We can start.
With my screen, okay.
Yes.
Just a minute.
Okay.
My computer, I don't know what happened with him, with it. Just a minute. Can another one speak with instead of me, and another I speak another time?
Okay, sure, okay. We can replace
Okay.
with another speaker.
Thank you.
Okay,
Just I make my mistake in my computer
okay,
and we'll
okay.
continue.
No problem,
Okay, thank
okay.
you. Okay.
Okay, the next speaker is Lida, and the title of the first talk is Application of PY for Electricity Generation in Tajura Heart Hospital ICU, Libya, applied at Near East Hospital. Marwa? Right now we can see your screen.
Okay, I will start. Thank you.
But now, no, right now we cannot. It disappeared suddenly.
Okay.
Just a second. Right now it's okay. Okay.
I'm a student of master degree in Altenbash University. My department, electric and computer engineering. I start about my introduction about my thesis or paper, magnetic resonance imaging for brain tumor and seizures classification of using a recurrent neural network. As first, I will beginning about my introducing about RNN based methodology of segmentation, a tumor as a seizures. My voice is clearly
Yes.
okay. And seizures for MRI imaging and determine the coloration for all diseases. For this several segmentation technique has been implemented and analysis in provided regarding the efficiency of the segmentation technique used. Each MRI imaging is passed through an imaging chain where the image is pre-processing produce sorry, to remove noise and further enhance and improve the context of image. The tumor region represented by a pixel value for the foreground point exacted using the MATLAB command for the texture image. The texture image is generated by apply the RNN method. Problem when I see it, when I make this, the major challenge I faced by me, exact, just a minute, to locate it and exact the proper tumor region for the image due to several lighting issues. Unnecessary white, then the portion where percent in the image which could wrongly be segments, and as a tumor also the unwanted noise and reduce the context display several regions from the image that wrongly are wrongly claimed as a tumor. Also extracting the structure feature from the image using proprietary texture filter in order to computer correlation coefficients was another major challenge faced. and problem exposure has been minimized greatly by applying appropriate noise filtering techniques like a median filter. The aim of a student, just a minute, that developed as a state-of-the-art brain tumor and seizures classification system on MRI image using the recurrent neural network in deep learning applied to brain image samples. We provide justification for selecting recurrent neural network as our base method, which is the further extended and the directly support male scale classification. The work also provided an insight into the theory blend current neural network applied to brain and describe the input and output response using representation used our network and provide the diversion to program propagation for use loss function. At the end, the network architecture used in the work. This makes the classifier capable to classifying tumor and seizures in MRI image for details, data sets. And I see in the literature review the tumor from the image by performing appropriate segmentation technique and morphological operation correlation performed determine the tumor extracted can be determined accurately determined as a tumor for the normalized cross correlation has been performed using the function of machine learning in the process where we compare the tumor extracted with the MRI image. The reason is based is because the CNN we determine MSER feature and plot the region based on the feature extracted using SVM algorithm. As a architecture diagram, I'm explain here in this architecture diagram, and then the methodology. The posted method initially involves apply different pair processing technique in the image, sharpen to sharpen the revolve portions into image after the RNN is applied. MRI magnetic resonance image created the magnetic field to the detect tumor that may be present to the organs and tissues. These MRI images are given as an input to our system for processing. Generally, MRI image look like black and white image on the computer. Technically, the white portion of the image has been larger amount of red, green, blue pixel, depending on the color channel. Hence, it becomes difficult to pre-process the image as a pre-processing is done on on monohosmer image. I make it by flowchart this and this, and then I'm plotting in this flow chart, and then I will explain this instructing an image into network and gray secting scaling in it on image after filtering is being performed. In grayscale imaging, the darkest possible shape is black, where the lightest possible shade is white. Remaining shade represents different shades of gray in image processing. It's often described desirable to have some amount of noise in the image. Therefore, to get a correct result, it is advisable to apply responsible smoothing filter to smear the image in order to get rid of the noise. Hence, we use the median filter to blur the image and efficient results. And we will get the result at the end. The RNN manages to show fairly accurate results for all images. The tumor region is represented by white portion for thresholding and image segmentation. In image segmentation, the tumor is represented by a gray region, whereas for MRI, the tumor extracted is colored in blue. For RNN, each of the layer is subplotted from where we can understand the layer in which the tumor is present. After exacting the foreground and background portion of the image, we have determined how the pixel in the tumor and seizures region are closely related to each other by computing cross correlation between largest target variable and tumor region. And here we are classification the brain tumor from MRI image sample using the RNN technique and classification the brain seizures from MRI image sample using RNN technique. The tumor region represent the pixel value of the foreground point exacting using the MATLAB built-in command, whereas the target variable consists RNN technique and use the represent skull region and represent tumor region and seizure region. This foreground and background points are obtaining using the MATLAB command from the texture filter image. At the first at this picture, it's classification of a brain tumor for MRI image sample using RNN technique. And for this image, I'm using classification of a brain seizures from MRI image sampling by using RNN technique. In the discussion, The results show that the RNN are powerful tool for image classification and research. The classification using an RNN technique pros- uh, proposed have been tested only in on 187 images for the data set. These images are taken under different lighting condition and different angles. Each methodology has some drawback and may work from some image for some images and not may not work for the same image. Using RNN technique to classify the tumor shows best results of the tumor region for the area rank and the segmentation value specified for most of the image as compared to other segmentation techniques. And this the comparison of the represents work with the exacting literature. Contribution to use the develop and evaluate the magnetic resonance image MRI for a brain tumor and seizures classification using recurrent neural network. Medical science and image processing is an emerging field which has presented a lot of advanced technique in the detection of analysis of the particular diseases by advancing in image processing. Various methodologies has been presented identify the tumor in the brain, and advancements in this field created an urge in me to research more on the technique and methodologies developed for tumor extraction. This technique involves different image processing methodologies such as noise removal, filtering, segmentation, and methodologies operation. And in conclusion, segmentation, the brain tumor has MRI from an MRI image and computing normalized cross correlation between the exacting tumor and MRI image. This value helps us to determine the tumor exacting has some noise percent and determine the level of actually of the extracting tumor and seizures. The foreground pixel and the tumor region and the background pixel are skull region. The tumor and seizures region represented the pixel value of the foreground points extracted using the RNN technique from the texture image. Using RNN technique in help us determine the level of the noise percent in image of the segmentation tumor based on the value of coloration. And thank you for listening to me.
Okay, thank you very much for your presentation. Is there
Thank
any
you.
question, comments, or remark? No question. Okay, I have one question. Is there an alternative imaging method for brain tumor?
What? I'm just listening to you.
Is there an alternative imaging method for brain tumor? For brain tumor, is there an alternative imaging method? How about the diffusion wave imaging or magnetic source imaging? Have you compared your result with these alternative imaging methods for brain tumor? Or diffusion tensor imaging? Okay. Okay. Last two presentations will be given by Dr. Lida Ibrahimi. The title of her first talk is Application of PY for Electricity Generation in Tajura Heart Hospital, ICU, Libya, applied to Near East Hospital. And the title of the second talk is Lighting the TRNC flag on the Besmark Mountain with Solar Energy.
Hello,
Hello.
my name is Lida. The name of the paper, application of the photovoltaic cell for the electricity generation in the Tanja Hospital, ICU. Just I will check for the ICU part for the hospital in the Libya and applied at the nearest university hospital. With Ahmed Ben Amira and me. He was my student before for the master, but now he's living in the Libya. When you check for the solar radiation for the Cyprus, generally the temperature here in the summer is very, very high, about 35 degrees centigrade to 40 degrees centigrade. Radiation is very high, temperature is very high. It's better to use solar energy in the Cyprus. But when we check for the Libya, we will see, in the summer again, it's very, very hot, but it's very cloudy and raining in the winter. When we check it, what is the difference between the advantage and disadvantage for the solar energy? Generally, the cost maybe is expensive then, but is a renewable energy. Lifetime is infinity. It's not similarly petrol or something because life 100 years, for petroleum. But advantage against about the technology development, but is friendly, is very, very friendly renewable energy. If we use, without pay money for the nothing for tax because it's a natural energy. How much solar energy coming to the earth? Generally 47% coming to the surface. After it's scattering by the dust or something in the atmosphere. Why we use the solar energy? Because fossil fuel is very, very dangerous for the health and is very, very, is not friendly with the environment, is not good, but nuclear energy is very, very dangerous, but solar energy, renewable energy, not all, but general solar energy is perfect if the radiation is very high in your city or in your country. Before to use this energy from the sun, you must be checking. Is it economy or is not economy? You must be take the data from the meteorological office. After that, you will be check which kind of the renewable energy is better to use in your city or your country. Maybe wind energy, maybe solar is dependent or biomass. This part we will compare in the ICU. In the ICU generally is important part for the hospital because when they directly electricity they cut the electricity, what happens is very, very big problem for the patient inside. ICU is very, very important part for the hospital. And we will check it. For example, if we know any chance for the using the solar cell, put it the solar cell, pay extra money or something, just maybe just we will use for the ICU, ICU part for the hospital. We have any data or something from the Taiju hospital and nearest university in the North Cyprus. When we check it, what is means of the photovoltaic cells? You know, photovoltaic cells is a PN junctions. Is a solar cell, material is silicon germanium. The direct is what? When the radiation coming and scattering to the solar cell, directly change to the electricity. But is DC, we must use the inverter and change to the what? AC. And you can use in your house. And with in this photo, they show, you know, what is means of PN junctions. Which one is, we have a hole and electron and junctions inside, and you can vote directly, you can produce the electricity with solar cell. When you check it about the type of the electric solar systems, we have a both three parts, the standalone system, grid systems, and hybrid systems. All this part from the data from the Libya about the wind, temperature, and radiation, all is inside. But it's very, it's important because it's dependent to your environment. If radiation is not very high, you don't need for use it, you know, because it's not economy. Here they, based on the measurements, calculation, technical center for next solutions, we have, for example, this one is not very new data, before 4 years before, but the number of the bed is not the same. They're increasing all. And no chance to me during these times, you know, we will go, I go and check for here, but I will check against, you know, but generally is the same for maximum load for in future bit for 20 bed. What happens, you know, okay? What happens for the maximum daily power? 49 kilowatt hour. Maximum power of the short-term loads is 4 kilowatt. The ICU will be powered only by a grid connected solar systems, because we have two systems, on and off grid systems. Is dependent, you know, you like to save inside the battery or directly to send to the network. This one about the radiations, wind or temperature in the Turkish Republic, Northern Cyprus. When you will check it from the graph here, the temperature is very high in the summer. Generally, it's very hot in Cyprus. It's not very windy, but solar, if we use the solar energy in Cyprus, is better. A study of the solar system generation in the hospital for the ICU, power from the 6 kilowatt hour, you know, in the Taiju hospital, and the PV system was closed and the alternative solutions to provide the ICU with required energy. This is a one photo from the Libya Taiju hospital. Load profile of 1 rooms with 4 beds and in the ICU, okay, in the month of the June. Now, what happens for the partial or measured load parameters during the survey? About, we have any data here about what happens for the voltage, number of the bed, and time of the survey, total conservations and daily conservations, what happens and what is the data inside. And maximums the data. This is for the hospital from the Turkish Republic, Northern Cyprus, in the nearest university. One photo from the hospital in the nearest university. nearest hospital has the most, is very, very important in the Cyprus, this hospital. And is very, very important against ICU part. All this data from the before, from the web team, from the nearest university, for the 4 units, general intensive care units that has 14 beds, and they show about how intensive care and non-typical intensive bed, and against about the profile of nearest hospital in the 1 day, against we have a data. This is a general, I know that generally they know that about, I hope so, but I am not sure, structure of the solar system. This one, what is means, is the online system. When after the product the electricity, directly we can send to the network. We have a, if you like, you can save in the battery or send. It's dependent, the position of your house maybe, or your hospital. If no any chance to send to the network, it is better to save inside the battery. Again, about the result of the power survey in the nearest university hospital, about what is the data for the voltage, number of the beds, and time of the survey, total conservations, and daily, and average. And we can see again about the maximum bed powers in this table. We use the data logger in the Libya. This one again is for the solar radiation pyrometer. We can collect all the radiations without take the data from the meteorological office. We can collect the data directly from the pyrometer. This is an inverter. We use it, solar panel. And for the system, for the Libya, what is the voltage, power, and what is the slope angle? Because angle is very important here. If it be increasing and decreasing, the radiations, and the performance for the solar energy is not the same. First, we must check it, which angle is better for your climate. Number of the panel. And against the number of the panel is dependent, against the quality of the power. Solar cell is not the same. And excuse me, AC voltage, and about the frequency, we have any data. And we collect with data logger. This is a graph for the open circuit voltage, short circuit current to the PV panel. The current against the voltage, they show what happens, to the curve here. Daily power generations. This is a graph against power against, when we sketch the power against the hour, what happens. Voltage, DC voltage to the, against for the hour when we check. All this graph for current against hour in the graph. And irradiations, what it means? Power per unit area. When we sketch to the hour, we can see, what happens to the radiations. Generally, we at noon, afternoon is maximum that we have. At the March, what happens for the power productions? They show when we sketch the power against day. And systems in the Turkish Republic, Northern Cyprus. Against about the DC voltage, what is the data? 400 volt, and maximum power, 250 watt over panel, Angle of, again, you know, what is the slope? It's the same, we decided at the same angle. Number of the panel is 20. Inverter, what is 5 kilowatt hour, and maximum DC voltage, AC voltage, and frequency. Again, for Cyprus, the same graph. We sketched the same graph. Power against generation for the Cyprus all. Against for energy for each day. And average monthly power generation, there you will check it for 2 years, okay? And you will be compared. You can see here what happens for the Turkish Republic, Northern Cyprus, and for blue one and dark blue one. Generally, we can use the same systems, not directly, the same in the nearest hospital or the another one, but it's very, very cheap if we use. But this is important, this part. First, money is expensive if you want to use solar cell for product electricity. But after then, what happens? You don't need for pay money every year for tax or something for the government, and easy. And directly when they cut the electricity is important part, for example, for hospital is very, very important again. This is an important part for the conclusions part because in Cyprus, here, generally we have not every time, but electricity we cut, but we need it for the, if we have a chance to use the solar cell, is better, but it's dependent to the first money against. This is important, you know that. The analysis of the collected data has shown that the system is produced approximately 52% of its nominal expended power. And for all this part, we use MATLAB software. And it was found that the efficiency of the incentive system during the spring month was better than its efficiency in the summer. The total energy production during the year was estimated to be 6,187 kilowatt hour. And this value approximately about 10,000 kilowatt hour. This was explained mainly by the use of the higher tilt angle that is more suitable for spring days more than summer days. But there is no any chance, for example, when you mount it, you know, at the one slope angle, every time it's not possible to change. Okay, we have any solar cell, you know, it's not fixed, you know, variable, and it will be changed, you know, until the sunset, but it's expensive then. If you compare it for the fixed solar cell, again, it's dependent to your economics. It's dependent to your money, which one is better, but it is better, we will check which perfect solar angle during the 1 year, which one is better. Generally is near the latitude data we can find. It's not possible every time we will change the angle in the 4 Celsius. Best ones check the latitude data for your country. In winter, change the slope angle to increasing the efficiency in the Tajur hospital. And in the here, electricity is very important in the ICU sections of the hospital. For what? For the patient. If the electricity is cut off. Thank you very much. If you have any questions. Just, you know.
Thank you for your presentation. Is there any question?
Thank you very much.
Comments or remark?
Thank you.
Sorry, I just have one question, please.
Please.
You compared Power
Oh,
generation. You compared the power generation in Near East University, Northern Cyprus, to the power generation in Libya. Okay. Now the comparison, because of the different.
Generally, you can use, because the climate generally is the similar. Is not very, here is, you know, the climate, the temperature is high, radiation is very high. Generally, you can't compare with together what happens, but the number of the is not the similar. If you want, I will show against the same slide. For example, for here, when you check it for Turkish Republic Northern Cyprus, okay, I didn't put it inside the one table, okay, because the slope angle, we decided the same data, and the number of the panel, 20, okay, and same inverter in the Libya, and DC voltage. If you compare it with the data for here, for the, just a minute, okay, if you check it, it's the same inverter. Can you understand? It's the same voltage, same power,
Yes, I'm
same
talking.
angle. I use it the same, okay? After that, we will check, you know, in the ICU for, we needed for how many solar cell. With, for example, now when you compare before, 5 years before, 6 years before, now we have any new solar cells, okay? Before then, for example, the power is not the same from now. Before 10 years before, if you compare from now, what happens? Against similarly, it will be what? It will be cheaper. It must be cheaper because it's the number of the factories it will be increasing. When the number of the factories, what happens? Production is good. It will be increasing. The price, it must be coming down. If you check it, is dependent against the size of your solar cell, which size you like. Because size maybe is the same, but the power is not the similar, and it's dependent to companies against. From the China, from the Germany you want to be buy, or from which country you like to buy it. Generally, it's not the same. For example, lifetime for the solar cell is about 30 years, but if you take from, I don't know, maybe by China, but product directly from China without, you know, checking from the another countries, what happens? The lifetime is not 30 years. What happens? You lose your money. If you compare, generally you can apply it, you know, for all, because we all the data logger, MATLAB, we check and we will decide it just for ICU part. Not all the hospital. General, you know, hospital for all the hospital in nearest university or Libya University, Tangier University.
Thank you so much.
Nothing, welcome. Thank you very much.
Okay, you can give the second talk.
Okay, give me just 2 minutes, please. Just a minute.
Okay.
Okay.
Right. We can see your screen.
Okay. Is it okay?
Right. Yes, you can start. We can see your screen.
Okay. Okay. Lighting. Just a minute, excuse me. Okay. Lighting the Turkish Republic Northern Cyprus flag on the beş parmak, thing with solar energy. They show the one picture from the flag. What is the PN junctions? They give any informations about what is the solar cell. It is made of the silicon and germanium, and directly the electron radiations coming and scattering to the solar cell directly change the electricity. How many types solar power system? On-grid system, off-grid system. Separated to the two systems. This is on-grid systems. In the on-grid systems, what happens? We must be sent to the network. And is it inside a solar panel, inverter, switchboard, electricity, motor, and electricity means grid. They show here what is the each so for product the electricity with solar cell and on-grid systems. This is for off-grid systems. For these systems, we must use both battery and against, save the energy inside the batteries. After when the sun sets, you can use directly from the battery. It's dependent when you want to be used, solar cell for product electricity. If no any chance to send to the government or to the network, what happens? It is better to use these systems. Another photo from the flag for the Turkish Republic Northern Cyprus. This is the show. We need it for how many or something for the illuminations for the flag. This part is start how many number we have, bulk distribution of the Turkish Republic Northern Cyprus, 40, this is we needed, 47 for MOOM, for TR, 248, and Turkish Republic Northern Cyprus, 432, all we needed for the illuminations, for the lighting of the flag. Future of the, when you will check it, about the length, they give me any data about 400 diameter and weight, area, number of the bulbs. Weight for the solar cell is not important, is 225 meter. Number of the bulbs, what's 432. Type of the bulbs, they wrote them. Type of the cable, bulb frame cable, they wrote. And all this information is directly from the government. Calculation for the flag electricity for one bulb, 80 joule/hour we have. When you will divide it by hour to change the second, you will be find, after the calculation, you will be find 0.022 watt. And you will be check it, what happens for the bulb for start, for MOOM, for TR, and Turkish Republic, Northern Cyprus. And after that, you will be changed to the what? Power to the joule in 10 seconds. Time and energy distribution of the flux bulbs. You can see in this table. For example, start first in the 1 minute, just 20 seconds, 2 minutes, 10 seconds, and they show for after 6 minutes what happens, you know, for each one. Time distribution of the flux bulbs tables. Another one, they show about the energy. The total energy in 5 minutes. And after that, during the 1 hour, what happens? After 12 hours, you will be checked is what? 1,328 kilowatt. We need it for the electricity, for the power. Now, this one is a sun time to the graph here. What is the highest sunshine hour? What is the minimum, maximum, by average of the sunshine in the Cyprus? And you will check from this table, this graph, you will see the average sunshine time on the Nicosia approximately 4.5 hours for a day. And here maximum night time approximately 10 hours, maximum night time approximately 10 hours. Calculation of the total power need for the solar system, they show in this table, calculation for the maximum night time. And against, you know, what is the data for minimum night time. And the system need to produce 4,963 kilowatt power per a day. Calculation for minimum night time against. What happens? The system needs to produce 3,541 kilowatt power per a day. It's not the same because generally for the night time is important. Is power is high then because during the day is not very high. Now performance on the grid solar systems. All here, any company, we took any data about the price, and after then, I check what happens. We need it for how many solar cells, and with, for example, the kind of the solar cell, about the power. When you check it all, for example, with solar panel, inverter, all, how many we need it for the lighting for the flag. For example, in Izmir, Turkey, this data from Izmir, Turkey, when we will check it, at which year? 2013, okay? When you check it, you will be find after the 9 years, you know, you will pay off, you know, 9 years is, you don't need for after then pay money for the extra for lighting for the flag if you use the solar cell. But when you check it here is interesting. 1 euro is about 3 Turkish lira. I changed this one 3 Turkish lira to the euro after that, and I compare what happens. Now you know that more now 7, 8, 1 euro now 7 Turkish lira or 8 Turkish lira is not the same before during the how many years? 5 years, because the another data is 2019. against for the another company. Just I will put it all this table just for what the all is not the same. For example, is dependent to the what? If it's 200 or 50 watt solar panel is not the same if you use the another solar cell, for example, to be 300 watts. This one, and again, you know, efficiency is not the same. Lifetime is not the same. I have any data for what? Compare with any factories with together for the lighting of the flag in Turkish Republic, Northern Cyprus. But when you will check euro at the 2030 is 3 Turkish lira, is equal to 3 Turkish lira, 1 euro. Again, for the another factories in the Germany product is, I know that the product in the solar cell in Turkey again, but I know that the life is okay, but Germany products generally is good product. But when you check the against, here is the similarity, 11.6 year. And in this graph, you can see, you know, what happens for the 4 factories, what is the, after how many years, you know, you don't need, you know, if you use your solar cell, you don't need for pay money against, for government, you don't need for money for the fuel, that's all. Now, this one for the which years, I check for the against 2019, what happens? If you check it, before 10 years before, for example, it's not possible you will find the, any solar cell with this power. But now the quality is better when you compare with the before then. When you check here, I change to the euro because I use the same data, okay? 30,000 Turkish lira, they pay for the illumination from the government, in which year? 2013. I didn't change against this one because I can't find any information in this year's, you know, okay, and 2019, I can't find, and against now I check, no any data how much money they pay government from the lighting for the flag in Turkish Republic, Northern Cyprus. I accepted the same, but I changed for the euro. What happens when you change to the euro? After the near the 5 years, okay, you don't need after then pay against for nothing if you use the solar cell, because lifetime is 30, and in this price, you know, during these times, every time tax or something, it will be increasing, maybe less than this 4 years, you know, you can pay off. This product from the company in USA, in America. We have any data from any companies, not just one companies. This one against the total cost they show for everyone. Against, you know, generally when you check about the 5 years, if you use the solar cell, is good without pay just 5 years, because now during how many years, you know, from the government they pay for money for the lighting for the flag. But if directly they put it the solar cell for the lighting for the flag, is economy then. Well, the same for the another companies. I check it for all what happens. At the results, when you will check, the guarantees is very important because the guarantee for all the solar cell is not the same. When guarantees is not good, for example, 10 years after, then when in the problem for the solar cell, you must pay extra money. When you will use the solar cell for product electricity, first we must be asked about the guarantee of the solar cell. Generally, when I check for any factories and compare with the 2013 and 2019, I can see, generally after the 5 years, no, 5 years, 4 years, less than 5 years, if you use the solar cell, is better than pay monies every time to the electricity. If you use the renewable energy, solar cell, is there maybe it is better we use the wind energy against wind energy and solar energy be together for lighting of the flag. The another future I will check for the wind because wind energies, but we must be put it any instrument near the flag and take the data for wind. If they use from government, if solar cell, wind energy, put it any turbine inside, I know is better for future because every year the price for electricity will be increasing, tax is increasing every time. That's all. Any questions?
Thank you for your presentation.
Thank you very much.
Is there any question, comments, or remark? No question. Everything is obvious. And thanks again for your presentation.
Thank you very much. Thank you very much.
So there is no more speaker, then we end up this session, and thanks again for your participation in this international conference. We hope to meet in other international conferences face-to-face.
I hope so. I hope so. I hope so, virus. It will be very fast. It will finish very, very fast.
I hope
And
so.
we will come again to Turkey for the conference.
Yeah.
I hope so.
I hope
Next
so.
year.
The next
I hope
year.
so. Thank you. Thank you very much. Bye-bye. Good time.
Thank you.
Good time.
Dr. Mary, thank you for your participation. And you can get all video records from the webpage of the conference in the next week. Eymen orada mısın?